So here we are today reviewing the factor patterns that we've studied over the last several weeks. And we're going to start with the basic binomial. And so all we're looking for here is two terms or one term that we can factor out that they have in common. So looking at this, hopefully you can see between a 12 and an 8, they have a 4 in common. And with an x to the 4th and an x, we have an x in common. So once we factor out a 4x, that leaves us with 3x to the 3rd, because 4x times 3x to the 3rd is 12x to the 4th. And if we factor a 4x out of 8x, that leaves us with a 2, because 4x times 2 is 8x. And this is the best and easiest factoring pattern. Short, sweet, and to the point. So here we go here. Now this one has a 3 and this has no coefficient except a 1. So there's no numbers we can pull out that they have in common. But we can pull out a y. So that leaves us with 3y minus 1. Because y times 3y is 3y squared. And y times negative 1 is negative y. And that would be our fully factored answer. Next, we have 20m cubed plus 30m squared. So looking at this, we can see between a 20 and a 30, we have a 10 in common. And looking at an m cubed and an m squared, we have a m in common. So then we have to think, okay, 10m times what is 20m cubed? So 10 times 2 is 20, and m times m squared is m cubed. And then we look to the next term. 10m, 10 times 3 is 30. M times m is 30m squared. And that is our fully factored final answer. Now we move on to the common trinomial, where you can see the leading coefficient is a 1. And these are our friends. These aren't so bad. So now we look at all the factors of 12. So we have a 4 times 3, a 6 times 2, and a 12 times 1. And now the whole goal is to add or subtract these terms to get them to add up to negative 4. So before I begin that, I am going to set up my parentheses. And we know when we FOIL the first term, x times x is x squared. So now let's look what we have here. A 4 and a 3. Noticing a 4 and a 3 could never add or subtract to be a negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. 4 minus 3 is 1. No way to do that. So that is not a possibility. Let's look at our 6 and 2. 6 minus 2 is 4. We're almost there. We want a negative 4. So the answer, it's going to be a negative 6 and a positive 2, because negative 6 and a positive 2 make negative 4. If you wanted to FOIL it to be sure it works, you do x times x is x squared. X times positive 2x is 2x. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. When you combine like terms, you're going to get x squared minus 4x minus 12. Notice that's our original, so that was our goal. So we're taking an equation and we're putting it in a different form so we can do different things with it. So that would be our final answer. If you wrote x plus 2 times x minus 6, that would be the exact same thing, and that's fine. Okay, next one. So we're going to start by setting up. We know if we do the first term, y times y is y squared. Now we're going to look at the factors of 35. And looking at this, we have only two choices, 7 times 5 and 35 times 1. And I'm hoping you select the 7 times 5, because negative 7 minus 5 is negative 12. So negative 7 minus 5 is negative 12. That would be our final answer. If you put y minus 5 times y minus 7, that is equally correct. Next, last example for this type, 25. Actually, I'm going to first start with the parentheses. X times x is x squared. And then I'm going to look here, and I know 5 times 5 is 25, and 25 times 1 is 25. And looking at this, my whole goal here is to get a negative 10. And hopefully you notice that negative 5 minus 5 give us negative 10. This is the correct answer. It is more correct to write that. However, both are equally correct, depending on what your final goal is with this equation. And that is our common trinomial. Now we're going to move on to the next type, where the leading coefficient is not a 1. So these include examples like this: 2x squared plus 7x plus 3, 3x squared plus 8x plus 4. And the last one we will do today is, okay. Now there are a number of different ways to use this. I prefer to do it visually and sort of play with it, because my goal is to get you all the way through to pre-calculus, calculus, and beyond. And doing this pattern-based makes it much faster in the future. So here, we know that 2x times x is 2x squared. And we know that 3 times 1 is 3. Now, our goal is to get it to add to positive 7x. So looking at this, I could either have a 3 here and a 1 here, like this, or a 1 and a 3, like that. And the easiest way is here. You can see 2x times x is 2x squared. So we have the first correct. Now we're going to do 2x times 1 is 2x. And we're going to do 3 times x is 3x. Is there any way to add or subtract a 2x and a 3x to get a 7x? And hopefully your answer is no. So that is not an option we can use. Let's look at the next example. So we know 2x times x is 2x squared. We know that 2x times 3 is 6x. And we know that 1 times x is x. And that's 3. Do you notice when you combine like terms, a 6x and an x give us a 7x, which is what we started with. So that is the correct answer. And both of these need to be positive, and we're done. Now this here, checking is not required unless your teacher requires it. This part is just to make sure that you have the correct numbers as they need to be, the orientation and place that they need to be. Okay, so now we're going to look at the next one, and hopefully you are okay with the fact that 3x times x is 3x squared. Now we have a couple of options with 4. We can do a 4 and a 1, or a 2 and a 2. So we can put a 4 here and a 1 there. We can put a 1 and a 4. And we can put a 2. Okay, so those are our 3 options. We know it's going to be one of those. Now, if this is confusing doing it this way, remember, be very patient. It's like riding a bike. The more you practice and the more you do it, the easier it will become. And in the long run, for when you get into upper division mathematics, this method is definitely worth it. So looking at this, now notice 3x times x is 3x squared. 3x times x is 3x. So all these options, our first term comes out to 3x squared. So all we're going to do now is focus on the outer and the inner. So if we did 3x times 1 is 3x, 4 times x is 4x. Now looking at this, can you add or subtract a 3x and a 4x to get an 8x? And notice there's no way to add or subtract those. A 3x plus a 4x is a 7x, and on and on. So we know this is not a viable option. Now we're going to look at the next one, and we're going to do outer and inner. So looking at this, notice 3x times 4 is 12x. 1 times x is x. Notice there is no way to add or subtract a 12 and a 1 to get an 8. That is not a viable option. Let's look at the last one. And notice we're only doing outer and inner at first. So we're going to get 3x times 2 is 6x. 2 times x is 2x, 6x, and 2x. Hopefully you're okay with that gives us 8x. And we did it. So our final answer is going to be 3x plus 2 times x plus 2. As I said, if you wanted to check, all you'd have to do is FOIL it, and you would get what you started with. Now we move to our final example. And we know 3y times y is 3y squared. What we don't know is there a 2 here and a 1 here, or a 1 and a 2? So we're going to try outer and inner, because we know 3y times y is 3y squared. So the first to take care of. So now we know 3y times 2 is 5y. And we know 1 times y is 1y. Oops, 6y, sorry. And notice we got it on the first try, because a negative 6, 3y times negative 2 is negative 6y. And positive 1 give us our middle term, a negative 5. And now let's check the last to be sure. 1 times negative 2 is negative 2. That is our final answer. We do not need to check the last one because we got it on the first try. Now we're going to move on to the final pattern we're going to cover today, which is difference of squares. So I'm going to give you a couple examples. And the last one we will do and be done is, there we go. So now looking at this, actually no, I'm going to just do, I don't know, let's do, there, make it interesting. Okay, so here we go. So difference of squares, if you see the pattern, is by far the easiest. So looking at this, do you notice that x times x is x squared, and 2 times 2 is 4. And when this occurs, this pattern, it becomes very easy. It's x plus 2, x minus 2. First one we'll check just to show. So if we FOIL that, we get x squared. X times negative 2 is minus 2x. 2 times x is 2x. 2 times negative 2 is minus 4. Notice those middle terms cancel, leaving us with x squared minus 4, which is exactly what we wanted to do. Again, a reminder, factoring is just putting an equation in a different form so we can use it in a variety of different ways. Let's look at the next one. Now hopefully you notice that y times y is y squared. What times what is 36? That's the same thing. And that's going to be 6 times 6. With a minus sign in the middle, that's going to be y plus 6, y minus 6. Next one, a little bit strange. M times m is m squared. N times n is n squared. Notice that's our pattern difference of squares. So we're going to do m plus n, n minus n. And that's going to be our final answer. Moving on to the next one. We have x squared y squared minus 25. Hopefully you're okay with xy times xy is x squared y squared. And 5 times 5 is 25. And this fits our difference of squares pattern, which makes it xy plus 5, xy minus 5. And that will be our final answer. Looking at the next, we have 49 minus k squared. So, again, we're used to the number coming after the coefficient, that's okay, or the variable. This is going to be 7 minus k, 7 plus k. Voila! And finally, x times x is x squared. 11 times 11 is 121. Meets our factoring criteria for difference of squares. X plus 11, x minus 11. And we are finished. That is today's lesson, reviewing our factoring. And stay tuned for more. Bye guys, I miss you. Okay, so we are just going to be finding an expression for area and perimeter. And we call it an expression because these aren't actual numbers that are assigned, these are polynomials that we're using. So finding area, hopefully we are okay with area of a rectangle is base times height, or length times width. And so once we get that, we get area is x plus 4 times x minus 4. Now hopefully looking at this right now, you're going to notice that you need to FOIL because this isn't quite simplified. So if you FOILed it at this point, you'd get x times x is x squared. X times negative 4 is minus 4x. 4 times x is 4x, and 4 times negative 4 is minus 16. And now we need to do a little bit of cleaning up and simplifying. And notice negative 4 plus 4x goes away, and we get x squared minus 16. Don't forget the units. Very, very important that we remember the units, okay? And now we're going to do perimeter. Hopefully you remember, and if you don't, I'm going to remind you that the formula for perimeter is 2 length plus 2 times the width, or base times height. So the length is x plus 4, and the width is x minus 4. And that gives us, when we simplify, we need to distribute that in and distribute that in. So we get 2 times x is 2x. 2 times 4 is positive 8. 2 times x is 2x. 2 times negative 4 is negative 8. Notice positive 8 and negative 8 cancel. Our final answer is 4x units squared. And that's our expression for perimeter. Oops. There, sorry. Perimeter is units. Area would be squared. Now going to the triangle. Okay, so let's start with area, and hopefully remember area is base times height. So area is 1/2 base times height. So our base is 2x minus 4, and our height is 2x plus 4. And looking at this, you could distribute in the 1/2, you could FOIL first. Remember with multiplication, in this case it does not matter. I'm going to go ahead and FOIL. So looking at this portion, I'm going to do the first. 2x times 2x is 4x squared. 2x times 4 is 8x. Negative 4 times 2 is minus 8x. And negative 4 times 4 is minus 16. Now we want to clean it up before we distribute in that 1/2. And that gives us, notice, positive 8x minus 8x is 0x, meaning there are no x's. So now we get 1/2 4x squared minus 16. And now it's time to distribute in the half. So if you distribute in the half, you get 1/2 times 4x squared. I'm going to take it to the side fractions for many students cause them pain and misery. So now we get, that's the same as that. Hopefully we see that 2 goes into 2 once, 2 goes into 4 twice. And this part simplifies to 2x squared. And now we're going to do the 1/2 times negative 16. I'm going to take it to the side if this is at all hard for you. Sorry. 1/2 times negative 16 is 1/2 times negative 16 over 1. 2 goes into 2 once, 2 goes into 16 8 times, and that gives us negative 8, and its area, so it's units squared. And that is what we do for a triangle. Now I'm okay, so we are going to find an expression for area and perimeter. Now this is a problem we're going to have to divide it up into 2 pieces. You can divide it either way, it doesn't matter. For no particular reason, I'm going to go that way. But we have to find all the sides, because perimeter is if you were to build a fence around it, how long would that fence be? Are you okay with if from here to here is 25 and here to here is 5? That would make this length 5. That would make this entire side 30. If this entire side is 30, this entire side is 30. So now we're going to, for perimeter, we're just going to go this side plus 30 plus, and we didn't label this. Notice if from here to here is 15 and here to here is 20, notice from here to here is going to be 5 because 15 plus 5 is 20. And if this is 5, then that's 5. So now we have plus 30, plus 5, plus 5, plus 15. Hopefully you're okay with that. It's 25. And then the last side we're going to add is 25. Now this might look like a lot of numbers, a little overwhelming. If you group them, notice 25 and 25 is 50. 20 and 30 is 50. So the perimeter is 100 units. Now I'm going to erase all the work. There it is if you need it. And we are going to find area. Okay, so for area we're going to break it up again, this time into 2 pieces. And we're going to get this guy here. So area of this is going to be length times width. And as we talked about, if this is 20, this is 20. So the length or base is 20. And the width or height is 25. And hopefully you're okay with, now we multiply those. And 20 times 25 is 500. And area is always square units or units squared. Now we're going to find the area of this guy. Now if you don't recognize it's a square and you use the formula for a rectangle, you would still get the same answer. And the length is 5. You can hear my dog's going crazy because the UPS man is here. And the width is 5. 25 square units. Guys, stop. So we're going to add that to 25. Stop! And we're going to get 525 square units total. So now I'm going to go shut the dogs up. We're going to do one more figure, the rectangle. So here we have, here and here, and we're going to make, what should we make that, 3. 3. And we're going to make this, be quiet. So next, Bluth, hold on. Bluth, stop. 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 Here, say hi to everybody. Come here. Say hi to everybody. He's my baby. Say hi, guys. Oops, I'm in the way. And there's other baby, Mila. Oh, no, there she goes. I don't know if you got to see her. Anyway. Okay, so back to this. Oops, gotta do it a little bit more. There you go. Okay. Can you stop? Stop. No, more. Okay. So now we need to find the height. So, oh yes, and you were also given that. There you go. So if we want to find the height, we're talking about here. And the height of a triangle is always perpendicular to the base, forming a right angle. I'm going to pull this triangle out and relabel it, because sometimes it can be confusing when it's embedded in a figure. And I'm just going to call this A, or B, or X, you call it anything you want. And I'm going to use Pythagorean theorem, which is A squared plus B squared equals C squared. Remember, C is the longest side and is always opposite the right angle. And as for here and here, it doesn't matter which one you call A or which one you call B, because they're the legs. So you're going to have A squared plus 3 squared equals 5 squared. Now we need to get the A squared alone. So we're going to subtract 9 from both sides. And then we're going to get A squared is 16. Now hopefully you remember, to get anything squared alone, you have to take the square root. So when you take the square root, you're going to get 4. So the height of this triangle is 4. Now some of you might notice plus or minus 4 is actually the answer, but the length of a triangle, any part of the triangle can't be negative. So we're only going to take positive 4. So now we take the formula for area. There we go. And 3 times 4 is 12. And half of 12 is 6 units squared. And that's the area. And now, perimeter, hopefully you are okay with. It is just side plus side plus side. And if each of these sections is 3, the total is 6. So we're going to get 5 plus 5 plus 6, which is 6. Oops, bad mistake. It's 16 units, not squared. And there's our final answer. So there you have it. Let me know if you have questions. Good luck with the homework, guys.